Whoa, look at this, a tornado in central Wisconsin, but it didn't form exactly how you might think. Hey, I'm Chief Meteorologist Tom Wachs. I want to take you through a really interesting and rare event, what's called a mini-supercell, and a tornado and several tornadoes that formed from it. Now, this was on July the 20th, 2026. This is from Nelson Tucker. You can follow him on Twitter at Tornado Study. Excellent content there. This was east of Wausau, Wisconsin, not far from Mattoon, Wisconsin. Now, as we take a look at the radar that night, I want to set the scene here. There was an enhanced risk for severe thunderstorms across most of the state of Wisconsin, yet southeastern Wisconsin and most of the state didn't see much at all from this. It was really a big bust perception-wise through most of the state. But as we look at the radar here, you see these little cells, tiny little cells that popped up. Well, more importantly than what you're seeing on radar is almost what you're not seeing. The radar site is in Green Bay. So as the radar beam goes out, if it's trying to look for rotation, for example, the radar beam is hitting higher up in the storm. So it can't detect rotation in the low levels in places like Wausau, Wisconsin. It's poor radar location, number one. Number two, as meteorologists, we look at how tall those storms get. And what was really interesting here, some of these storms were not tall enough to even produce lightning, meaning that the storms were not tall enough to get the ice in the clouds, to get the charge separation and the lightning out of it. Some of these storms only top to 30 to 40,000 feet high. I know that might seem high, but when you're talking about tornadoes and big-time severe thunderstorms, you really want to be in at least the 40 to 50,000 foot range, and sometimes in places like Oklahoma, you can get up to 70,000 feet high. So these were very low topped. Really odd, to be honest, and there were even reports of tornadoes on the ground without tornado warnings at first because they just weren't being detected, in part because of the poor radar coverage. Now, as we take a look at the storm reports that came out of this, several reports of funnel clouds and tornadoes from this. But let's go back to Nelson's picture here, because notice a couple of things. Number one, you see the tornado on the ground there, but also look towards the top. You see the cauliflower looking area there? That's the thunderstorm updraft. It is, first of all, not very tall. You can clearly tell it has not reached what's called the tropopause, or the top layer of the troposphere, because it's not anviling out as most severe thunderstorms and supercells do, where they reach the top of the troposphere. You can't get into the stratosphere because it gets warmer, so it fans out into an anvil-like shape. You're not seeing that here. Again, little odd, right? Well, let's dig more into this as to what's going on. So in this case, you had the updraft, or the air going up into the storm. There was a tremendous amount of wind shear. That's the changing of wind direction and or wind speed with height. That essentially was the rotation portion of this. But there was limited instability closer to the surface, or low CAPE, which is convective available potential energy. So though that was the atmospheric parameters that were in place, but then there was dry air entraining or moving into the storm, which weakened the updraft, preventing the updraft from growing into that massive supercell that you might typically see. So this was a mini supercell that generated several tornadoes. There were several of these mini supercells. Again, very strange, not very common, but it was the mixing of the atmospheric conditions, the high-shear, low-CAPE environment, combined with the dry air aloft, preventing the storm from really getting going. Plus, there was also that dry air aloft. There was some warmer air aloft as well, a capping inversion through a large part of the area. So then you tack on the fact that it was in a bad radar zone effectively as well, because of where the radar site was and the curvature of the Earth. So this was a very odd event, but let me give you the takeaway from this here. I mentioned there was an enhanced risk. The wind shear in this case compensated for the fact that there was the dry air aloft and there was lower instability or lower CAPE. Imagine for a minute if those storms had really gone full blast, if that had been a regular massive supercell, as was the forecast by the Storm Prediction Center. These things would have been huge tornadoes. I mean, they were sizable in and of their own with the mini-supercell structures. Imagine if these had been regular supercell structured storms. I mean, these would have been extremely strong tornadoes, in my opinion, given the strong wind shear. If, again, we didn't have the dry air aloft, if we didn't have the capping inversion, if we had had more instability at the surface. And I also think lift played a role in this as well, meaning that we just didn't have a lot of lift from the vorticity advection aloft and also the front at the surface. But, again, just going back here to the photo, this is incredible. And the science here is really incredible. So a lot of folks, after this event said, wow, I mean, this was such a bust, right? It was such a bust. Milwaukee didn't even get a raindrop out of this system. So yes, it was a bust in the sense that we didn't see anything, but it was really a marvel from a standpoint that we got these mini supercells producing tornadoes, which is very, very rare. And it goes to the fact that if the other ingredients had been in place, meaning the lack of, if we didn't have the dry air, we didn't have the cap, and we had a little more lift, if those storms had really gone, it would have been a much different day across the state of Wisconsin, as was forecast with that enhanced risk. But again, mini supercell tornadoes, not something I've encountered much in my career, and the science of it is just extraordinary. And again, I want to give credit to Nelson Tucker at Tornado Study there on X for that incredible shot, and the science just amazing.